rotating, you can hear 100% infield. Huge thing here. This is also on island. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm tube. Whoa. Be mine. All our different materials. How do you guys like this? I think we are live. And again, I did all my introduction without the audio. As always, I always like sometime when I put the video at the beginning, then it mute automatically. But sometimes I just force the mute, and then of course when the intro finished, then I forgot to unmute. So I was saying hello to everyone, and then I saw Steve Builds, and then he made me remember this name, and then I just checked, and indeed, it's the Voron creator that I still need to contact, and I haven't, the one you presented. Yeah, thank you everyone for highlighting the audio. I think that's the third time or the fourth time that I'm doing my muted intro. So I guess you guys are used to my muted intro, right? You will practice reading my lips. Okay, so today that's the second episode of the Q&A. So the idea is we can go straight into that. If you have any question on 3D printing, you can ask. It doesn't have to be related with the topic we have. You just throw all of your questions, whether it's printer related, material related, news, other companies that you would like some feedback on, or any questions. Please throw them on the chat, and then at the same time, I'm gonna go through the Reddit. I don't think it's 3D print. Is that this one? Yeah, it's this one. And then they have like thousands of questions every week on this one. They have the question flare, I guess. I don't know why they call this flare. What's that? Does that mean topic? Flare definition. I guess it means a special incentive, aptitude, or ability for doing something well. Okay, I don't know why they call this flare, but anyway. So if there is no specific question, then I will do like last time. We just go through Reddit, and then we answer all of the questions there. So I think we're good to go. Yes, it's good. No, it's good. The audio should be good. The internet is not bad. Hopefully, it's not gonna drop too many times. But I think it will. It will a little bit. And then can hear you, but can see that. Yeah, Steve Bills and Steve Bills. I need to contact you for some. I've been contacting the Voron team for a while now, but we haven't been able to make some project work. So a lot of people recommended that I reach out to you directly and see if we can make some projects. So I will definitely reach out. Okay, let's go. So we've chatted before. Oh, really? Okay. Yeah. Sorry, I have so many different. I'm late on so many different things, and then many messages. And was it on Discord or on Twitter, or maybe I can check back the discussion. Okay. So how do I remove the material within the cylinder? So looks like this is more of 3D modeling, but it's okay. It's 3D printing related. Let's check the picture. How do I remove the material within the cylinder in Blender? How do I remove the material within the cylinder? Well, on Blender, it works the same as any other 3D modeling software, right? You have a Boolean tool, you create your cylinder, and then you put another cylinder inside, and then you select the first cylinder, and then you go in your tool Boolean, and then the difference, and then you select the other cylinder, and then it's going to remove it from the middle. But you have to close the cylinder, because if it's like this, then it just acting as a surface. The second one, seam layer change. Oh, did you see how fast the internet is? That's amazing. I'm not used to that. That's okay. I know how it is. I owe you some information anyway. Okay, on Discord. Okay, I'm gonna check that then. Oh, on Discord. So that means that was recent. Oh, my memory is so bad. Okay, sorry for that. I'm gonna check that. Seam layer change causing print defect. Okay, so that's the defect area. Okay, so it looks like, yeah, I've seen this a lot. When you finish your layer, then is under extruding, so you can see that it's actually starting to under extrude before it even finished the layer. And every time I see this, oh, by the way, you have some warping as well, looks like. But when I see this, I'm always wondering whether it's the starting of the layer or the finishing of the layer. Is it the nozzle that has difficulties to build up the pressure when starting the layer, or is it the nozzle that has the extruded amount that is not enough to finish the layer? So let's see if there is some a little bit more information. Any help with me? I've done many Google research, not available, specific problem, blah, blah, blah. Looks like under extrusion and retraction so far, blah, blah. Okay, some stuff about retraction. Lower retraction, ton of costing. Yeah, so they all assume. So my first question when I see this is always the same, because I've seen this a lot. And usually it's the end of the layer, usually. Hi, Plastic Guts. Do you know which of your filament is the best for annealing? Which of the filament is the best for annealing? What does that mean? Like, sorry, I don't understand your question. Annealing is a process. How can a material be good at annealing? Do you mind putting a little bit more detail? I mean, we have nylon that there's a lot of material you can anneal for different reasons, right? Some for crystallization, some for releasing internal stress. But I don't understand what you mean by which one is the best for annealing. Okay, so again, that's the first question I would ask, but it seems that nobody asked. So let's assume this is the end of the layer, right? So if it's the end of the layer, that means the pressure, the extruded amount is not enough. So it could be, let me check. It could be that, yeah, what it could be actually. it's definitely the material not enough to finish the layer. But what could be the reason of this type of under extrusion? Hi, Mark and Draka. Oh, by the way, I've, I'm seeing Mark and Draka, and that reminds me about this that I completely forgot. And then this. Oh, I'm surprised. I'm surprised nobody remind me. Which is good, right? There you go. Okay, sorry for that. Mark and Draka represent our giveaway. That's why. Yeah, I'm not too sure what this could be. If it's the end of the layer, then I'm not too sure, because some people were saying, check your costing, so which means the F lower retraction. So you see, this is basically, if it's lower the retraction, then it means it's the beginning of the layer. If it's turn off cost, then it's the sorry. If it's lower retraction, it's to solve the problem if it's the beginning of the layer. If it's turn off cost, it's to solve the problem if it's the end of the layer. So actually the right question here is it the beginning of the layer or the end of the layer? If it's the beginning of the layer, then yes, I think retraction could be the issue, because if you retract too much and then somehow it oozes or something, and then you arrive on the new island and then you print again, then you will have you will have this issue, because you will have difficulties to build up the pressure. And once the pressure is good enough to extrude properly, then it already finishes a few edges of your print, and then you will start printing properly. If it's the end of the layer, I'm not too sure what could be the problem, but usually it's the end of the layer. And you know how you can check that? Actually, I think you see the how do you call that, the ridges here on the side could indicate that is going this way. So it looks like it's the end of the layer. But costing, I don't think is costing, because costing is usually a few millimeter, but it's starting to under extrude like a few centimeters before. So I'm not too sure. Let me check. Okay, having a metalworking background myself, I know annealing as meaning to soften the material. I've noticed that in the 3D printing community, people use the term annealing to refer to baking their print to make it stronger. Okay, so your question is, which material provide the easiest, most user-friendly annealing? Yeah, again, I'm not too sure. I've noticed that in 3D printing, people use the term annealing to refer to baking their print. Yes. So you annealing in 3D printing has two meaning. Meaning number one, if you are dealing with semi-crystalline material, you put it in the oven and then you crystallize the part. So this is for semi-crystalline, and then crystallizing the part will increase the heat resistance, will increase some of the mechanical properties of the part. But there is no particular polymer that will anneal better than another. They all do the same. You put it in the oven and then you put it at a certain temperature for a certain amount of time. They're all the same. So there's no one that is better than another. If you say better if you anneal them, they will have a greater mechanical property than other. But I don't think that's your question. And then so that's one part of annealing. The other part of annealing is the 3D printing process is going to create a lot of stress in the material. So for amorphous material like polycarbonate, for example, after you print with polycarbonate, you put it in the oven to release all the stress. If you don't release the stress, then over time you will create some micro cracks, and then you will lower the mechanical properties of your part. But again, there is not really a meaning of a best for annealing compared to comparing the different polymers. If you are trying to get a vibrant color, I figure it takes a lot of dye. Doesn't this affect the material strength in some ways? Yes, it does. It actually affects the printing quality. And then if you affect the printing quality, the flow when printing, then it will affect the material mechanical properties. So yeah, it's when we develop new colors, it's always a trade-off between the amount of color master batch you put in the material and the printability. For example, you can see that our which one? I think our Polylight ASA white. I think if you notice, it's kind of it has like a painting look, and because we had to to make it very white, we had to increase a little bit the concentration of master batch. Yes, I did mean which one would create the strongest mechanical properties. Okay, then again, one of the high performance material, like maybe I don't know, high temperature nylon or PEEK or PEC or this type of polymers. No, you're not stupid. We're here to I just wanted to make sure I understand the question well, so that I can understand properly. Is annealing two parts printed with the exact same setting will result in the same dimension changes? Yeah, if it's the same material, if everything is the same, then yeah. If your printing setup is the same, the G code is the same, the material is the same, and then you anneal both, then it will both shrink in the same way. If it's for crystallization, then it will shrink. If it's for stress release, usually it doesn't change much the dimension. Hey Caleb, am I late? No, you're not late. Yeah, again, I don't know if you have some suggestion, but if this is the end of the layer, to be honest, I don't have a clear idea of what could cause this. Like, because in my mind, yes, it start the layer, no problem, and then it just go all around, and then suddenly, for some reason, it stopped extruding properly. So either because the G code, the command is, you do your edges, and then there is the right amount of material that you extruded. But for some reason, for the edges at the end, then it doesn't have enough. So I'm not too sure what could happen here. Usually, when I see under extrusion, I recommend to higher the printing temperature, and that usually solves the problem. So in this case, if a user comes to me with this, then I will usually recommend the printing temperature. And if it's the beginning of the layer, then I will talk about retraction. I need to be careful with retraction. If it's the end of the layer, I will usually only talk about the temperature, because I don't know what other things could affect this. Costing, I don't think so, especially that bad defected area. Yeah, linear advance could be, but I mean that's pretty severe, right? Or you have linear advance, and then it's very it's not calibrated at all, and then you have this issue, because linear advance usually don't deal so much with under extrusion. I mean, yes, under extrusion, but not that severe. It deals with the thickness of your line width, right? But if it's that severe, like that big under extrusion, then there might be something else going on, or your linear advance is reversed, right? Or it's completely not calibrated properly. But I don't think he is using linear advance. Otherwise, I don't think he would. I think he would have figured out by himself. So that's my guess. Next one. My extruder consistently stopped extruding during the first layer of infill. Any suggestion? Okay, so what usually happen here when you have your bottom layer that prints very well, and then have a certain, I'm dropping a little bit, but I should be back now. So usually the bottom layer will have a certain speed, like 30 or 40 millimeter per second. I'm not talking about the Voron, right? I'm talking about regular standard printer. But yeah, the bottom layer should be around 30 to 40 millimeter per second. And then suddenly the infill is going to ramp up to 60, 70 millimeter per second. And then usually, if your temperature is not right, then it's not going to keep up with the speed. So what I would recommend here is to higher the temperature or lower the infill speed. So the best here is to do the CNC kitchen test so that you know exactly what your printer is capable of. And then you can check your G-code, or you can check your preview to see if the volumetric speed of your whole print is within what your printer can do. So that's the best way to solve this issue. Just popped in to show support. Thank you very much, Vice. And I know I owe you some answers. I'm getting there. I see wood graining, extruder vibrating, ending up in the print. I see wood graining, extruder vibration ending up in the print. Do other people have issues with silk filament jamming? Yes, there is a lot of people that has this issue. Multiple reasons. There is some silk formula that are mixing that are more flexible than regular PLA, and that flexibility sometimes the extruder has difficulty to deal with. The other things, if you're talking about our silk, especially if you're used to our regular PLA and then switch to our silk, there is a major difference. Our regular PLA has jam-free technology, which means the heat resistance of the PLA itself, the filament itself, not the printed part, the filament is 140 degrees. So this PLA can be printed in a all metal hot end or at a very high temperature without having too much heat creep issue. But the problem with our silk is that it doesn't have, our silk is a regular silk. It doesn't have jam-free technology. So if you're used to printing with our PLA and then suddenly change to silk, then you have to be careful with heat creep, or you have to be careful more than our regular PLA. What subreddit? This is 3D printing. You go 3D printing community, and then you rank by new, and then you only take the question, and then that's where I am. So I want to make sure I don't miss any questions. So the goal is to answer all of your questions first, and then I just use the subreddit to get some other questions. Where is this print picture? Yeah, I just told you. Actually, you know what? I can share the link. So this is where I am. So jamming, we got that. Is Polymaker ever going to make a rainbow silk PLA? Yes, we are. We've talked a lot about this on our Discord, and Tonyue, our product manager, is updating everyone on the advancement of all our new product. By the way, if you want to be the first informed on what's going on with Polymaker new product, you can join our Discord. Discord.polymaker.com, and then we communicate more about what's going on at Polymaker there. What about quantum style? Yes, also we're developing both. I mean, we finished developing them, but now we need to make sure we do some printability test. We do color matching and this type of thing. That makes sense. What do you recommend for silk PLA for temperature, and do you slow the print down? So usually people print silk PLA as 225, mainly because the higher the temperature and the more silky the finish is. But that would depend on how good your hot end is in terms of heat creep. If you can print at because some people print at 210, because if they go 225, 230, or 235, then they will start to have heat creep issues. So that depends on how good your heat creep management on your 3D printer is. You can try 225, and then something like 215 limited to 2 millimeter cube of flow can probably go faster. Yeah, so Zombie also answered that. So usually 225 if you want a very nice silky finish at 50 millimeter per second for the outer shell, and that should work. And if this jams the printer, then either check if the fan for the cold end is working well, or most likely it's a heap creep issue. Just printed the most PLA CF benchy. Great. Congratulations, Dev. Which PLA CF have you been using? I print my silk at 200 with no issues. Yeah, I mean, you can print at lower temperature, but I think the silky finish will be less, like depending on what you like. Some people like a more matte silk, I guess, finish compared to a very, very silky, shiny finish. Firmware, yeah, I'm very bad at firmware, so maybe not this question. Is this much oozing expected? Extruder not extruding, by the way. Well, it depends. It's hard to in this case, this is where let me think. So this is interesting. Like we can try to understand why would the filament be extruded, but the extruder is not extruded, right? Do you remember we were talking about if you extrude a certain amount, then you have the same amount that comes out, right? If you have the system, if you remember that discussion. And now we have nothing that is pushed in, but we have something that come out, right? So in that idea, then in my mind is like this: the system had pressure. Okay, so you can think about the printer extruding the filament, and then the nozzle slowly cool down, and then at a point where it cannot extrude anymore, but there is still pressure from the extruder. So even if the extruder is not moving, you still have residual pressure in your setup. So once you start a new print, then you're going to raise the temperature, and as the temperature raises, then all of that residual pressure will be enough to start extruding the filament. So my guess is, whether it's too expected or not, I don't call this oozing, because during the 3D printing you are going to do a retraction. So if you do a retraction before and then you check the oozing, then that's the kind of oozing you could check if you are designing your nozzle, for example. If you are designing a new shape of nozzle, do you remember last time we said that the nozzle design is very important for oozing? Then you can do this test, but don't do the test where you just heat up the nozzle and then check what's coming out. You have to do a retraction before. You have to get rid of the residual pressure before, and then you can check whether it's big or not. Just printing, blah, blah, blah. Wouldn't that be dependent on the viscosity of the molten filament? Yeah, definitely. So if you are talking about the oozing here, then yeah, so you have a residual pressure, and then the pressure required to extrude the filament is dependent on the filament viscosity. So when you start your G code, then some of the first command will be to heat up the nozzle. So as the nozzle heat up, the viscosity of your filament goes down, and at some point it will be low enough so that the residual pressure can push the filament out, and then it will continue going down, and then the residual pressure will be able to extrude more and more, and then you will start to have equilibrium inside, and then it will stop extruding. What I do to avoid oozing is to all my calibration with the nozzle at 180 degrees, then only heat up directly before my purge line. Yeah, I mean, I'm not sure if we call at the beginning if it's oozing, but I guess yes. I guess that's the beginning of the print ooze. Under extrusion in the same spot on the benchy. Interesting. Okay, let's check this. So, for example, when I see this, I'm wondering if you print 2 times the same G code. There is a lot of time when I troubleshoot. I always ask, if you have you printed the same G code 2 times. I mean, if it's a small print, then I ask this. If it's like a big print, then of course I'm not going to say, print it a second time, waste another kg of filament to see if it's the same. But if it's a small benchy here with marble, especially marble with all of the powder that could clog the nozzle, partially clog the nozzle, then in this case I would say the same. Print the same, and if you have exactly the issue at the same place and everything the same, then it can give a lot of information. But in this case, I would say in this case, the extrusion, you have some very small island, right? And when you have a small island, the flow is much harder to manage. And in this case, you're printing a marble, so it could be that in this small island is much easier for the marble to accumulate. Why? Because you're extruding a little bit, so you're pushing, and then you are retracting, pushing, retracting. So you're kind of accumulating all of this small powder in the nozzle, and maybe it can partially clog your nozzle, and then once you re-extrude again, then it will be fine again. So in this case, I'm saying this because it's happening on small islands, right? These 4 islands, the 4 pillar of the benchy, and he is printing with a marble. So that lead me to say that that's the reason. So to solve that, I would increase the printing temperature, or is there anything else? Or I would lower the retraction, maybe especially for this point here. So this would be it's a pity nobody is helping him. But that would be my recommendation for here. You should print a tall print to see Z issue like a square. Yeah, that's also useful. Polytera seems to need much lower retraction for me than other PLA. Any idea why? Is the material firmer when heated than regular PLA? Needs much lower retraction. It could be because Polytera has a higher shear thinning effect than the other filament. So shear thinning. I'm not sure if my pronunciation is correct, so let me write this down. Shear thinning. So it has shear thinning. It has a more severe effect, or how to say, the effect of shear thinning for Polytera is higher than regular PLA, which means Polytera would require a lot of shear stress in order to flow properly. And what does that mean? It means that if you stop extruding, then it won't ooze, not as much as other PLA. So you don't need a very high retraction. So that could be the idea. I'm thinking about other things, but that would be the first thing that come to my mind on why Polytera would require less retraction than a regular PLA for the same result. Nozzle in the heated bed. I'm new to the 3D printing, blah, 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 blah. I like when there is picture. Okay, here's picture. What caused this imperfection happens at the same layer every time. Okay, interesting. So he printed this multiple time, I guess, and he has this under extrusion always at the same layers. Happen at the same layer every time. On the same height or different models, check the Z-screw for damage slippage, or perhaps your layer height is a weird number that your specific motor controller struggle to hit at that spot. I mean, to be honest, here I can see a lot of under extrusion, not only here. I mean, under extrusion here, under extrusion here, under extrusion here, maybe a little bit here. So definitely I would recommend higher temperature, lower speed. Just the regular under extrusion suggestion, because it's not only at this layer, it's under extrusion the whole print pretty much. New to resin, why does the filament keep jumping? Keep jumping. Oh, okay. So extruder skipping. So that's the same. Extruder skipping means the viscosity of the filament is too high to be pushed at that pressure. So again, this is, you do the CNC kitchen test so that you can understand the limitation of your printer. You have that part, or you have a nozzle clog, or you have a nozzle jam. So jamming means the material expanding in the cold hand, or you have a clog, means you have a carbonated polymer in the nozzle that is clogging it, or he's not printing with marble or any particular effect filament. So it could be one of these. Either your printer has reached its limits, either your printer has jammed in the cold end, either the nozzle clogged. So it's one of these. So you can check. Or the nozzle is too close to the surface. Yeah, also it could also be like, basically, something is blocking the exit of the nozzle. Hi, I'm new to 3D printing. Can someone help me fixing this problem of shifted levels? My specs are in the comment. Thank you. Shifted. Okay, so I guess he's talking about the layer shift, right? Blah, blah. Non-Ftun Mini 3D printer bought on Amazon, less than 100. Slicer Cura. I had this problem now like 3 times with different object, but in between I printed some other stuff that came out fine. Is there anything? Okay, so when I see layer shift with regular PLA, then I'm thinking a very weak stepper motor, usually. Especially, I mean, I have never heard about this printer, but there is a mini in the name. It's less than 100 euros, so I'm not sure. It could be a very weak stepper motor that didn't handle one of the jerk move, which means the instantaneous speed change at some point, and then they just skipped, or the nozzle got caught on a curled surface, and if the stepper motor is very weak, then it doesn't take much for the stepper motor to skip step. So I would lower maybe the jerk. I would lower the jerk. I would double check if there is any curled on my print that could have caught up in the nozzle, and then that's how I would solve the problem. But I think mainly it could come from the printer. What I guess is the print that came out fine most likely was some small print. When you have bigger print, then you have a higher risk of having that layer shift issue. That's my guess on this problem. Okay, getting what is this? See full image. Well, how are we supposed to troubleshoot this image? There's nothing. Most likely his problem is a camera problem, not a printer program. Getting this issue on both my printer using Cura and Super Slicer. The printer head will stop for a split second and then keep going, cause a blob. It's not consistently happening in the same spot. I turn off power loss, blah, blah, blah. Seems to not happen on smaller print. Okay. Got it. Okay, small blob here, and then there's another picture, and then some blobs here. Okay, so I had this issue when I was trying to print our TPU95 HF, the high flow TPU on Ender 3 at a very high speed. So I printed a vase mode. In vase mode, I printing TPU95, and I think I reached 150 millimeter per second, and then it would just print TPU like in circle like this, like a vase mode. And then when I started going higher in the speed, then somehow the print head starting to stop a little bit. Like I could feel that the printer struggled to maintain that circular motion at high speed. And then I started to have this small blob here. So maybe he's pushing the printer to a point where it doesn't handle, and especially that it seems that he's printing in maybe actually I'm not sure, but it could be a vase mode, and maybe he's pushing the printer to the speed limit, and then somehow it will start to skip some stuff, and then it will stop a little bit and then continue. So that's my experiment with the Ender 3. When I print in vase mode very fast, it will start to stop, and then I have this blob that are accumulated. So I'm not sure what print speed he's at. But when I watched the printer, I had the same issue, and that came from there. Do you, Jonathan? Do you guys measure the opacity of your filament? I was doing a project where I was switching after only 2 to 3 layers and was having color bleed through problem with some filaments. So the first question: do you measure the opacity of your filament? No, we don't measure that. And I was doing a project where I was switching after only 2 to 3 layers and was having color bleed through problems with some filament. Sorry, what do you mean? Do you mean like you print 3 layers and then you stop your printer, you change the filament, you change the color, and then you print again, and then the color that you just printed started to bleed through the first layers? I was doing a project where I was switching after only 2 to 3 layers and was, yes, really? I don't know. I've never experienced that. So you mean, so you're printing, for example, you're printing white, 3 layers, and then you switch to black, and then the black will start to like contaminate the white, and then the white will become a little bit black. Well, I've never experienced that. This is very strange to me, because polymers, I mean, the color master batch shouldn't, if you have one layer in black and one layer in white, they shouldn't share the color. I mean, they shouldn't like transmit the color in some ways. So I'm not too sure. Black to white, yes. White showed the black underneath. Oh, you mean, so it doesn't bleed, the color doesn't bleed in the other layer. It's just when you look at with the light, then you can see through, right? Like you can see the black through the white. I guess that's what you mean, right? Yes. Okay. Yeah, then I don't know, maybe you can print more layers in between, but yeah, some like our raw PLA, if you want, you can use Polyterra. If you use Polyterra PLA, you shouldn't have this issue, because Polyterra PLA raw materials is an opaque filament. Our regular PLA formula is a kind of a translucent raw material. So for translucent raw material, even if you add the color, if you put it on the light, then it will still be a little bit transparent. For Polyterra, is much more opaque. So if you're looking to do that without that problem, then I would recommend to switch to a more opaque material. So I'm thinking Polyterra PLA. I'm thinking Polymax PLA. So Polymax PLA also, it's a special formula. It's not translucent. Polyterra PLA. And then Polylite PLA, no. PTG, definitely not. Yeah, so I would recommend this too. We don't have a specific test, but if you're asking me which one are opaque, which one are more translucent, then I can answer. Yeah, maybe the control board bandwidth is saturated by too many instructions second. Decreasing a bit the resolution of the model can help. Circle are made of many small. Oh yeah, that's also a good point, non-fam. The amount of command your board can handle. So depending, if you have a vase mode, and then you use a lot of subdivision for the edges, then when it's going to slice, it's going to have like for example, one circle could have like, I don't know, 200 command. Then you can lower that circle to I don't know, 50 command, and then that would be maybe you can handle it. That's a good point. Sounds like the wall was too thin. The wall was too thin. I'm not sure if this would. Yeah, I'm not sure for that one, because it's really the hot end stopping, and then that's why it's over extruding. So I'm not sure regarding the wall size. The next one, how to get better result using tree support. To be honest, I'm not a big fan about tree support. If you want a very good a very good surface finish. Tree support is what I don't like with tree supports is it's a little bit like SLA. If I remember well, the tree support only have point to support your structure, but I prefer having a surface to support another surface instead of point to support a surface. So I don't know what he was using before, but if he was using tree support and he want to improve, like how to get better result using tree support, then my feedback is don't use tree support. Use regular support. You should have better result. But I'm not a big expert in tree support because I just don't like it without even trying it. So that might not be the best. But that would be my recommendation here. I know with regular support you can get much better. I don't know if with tree support you can get much better. Um, Hi Andrew, thank you for joining our Q&A. Tree support are for miniatures. Yeah, I've seen. I mean, the tree support. What's the advantage of tree support? Is that material saving, or what else? Except saving material, what else do you gain out of tree support? Um, okay, I'm back. I had to fix the clog. Nylon worked well for that. It looks like there was some carbon fiber in the nozzle. Yeah, maybe printing at a higher temperature for a better flow. Tree support should be fine. Okay. Bridging issues cause that. Yeah, that's why the tree support you'll have. What I like is regular support with support interface, and then that's what I like. It's difficult to remove. I agree, but the surface quality is very good. So that's my favorite, support with support interface. I don't know if tree support can have tree support structure and then do a bridging for the support interface, and then has a nice support and then print on top. Then that would be awesome. Um, yeah, it really depends on the filament. Like you said, this could be measured by shining light through and measuring the amount of light that hits the other side. Yeah. Yeah, we could have. I mean, we have a color machine. We don't have a opacity translucent machine, but yeah, we haven't received so much demand for that particular data. But I can definitely help you finding our most opaque filament just by experience, just by looking at the raw material itself. Tree support can support the inside of the model without touching the model. Yeah, that's true. That's true. It can do like you can print a big overhang with the tree support, and then you go and support the inside of something. Tree support, material saving, time saving, easier to remove. Okay, material saving. Okay, and then material saving, time saving goes together, I guess. And then easier to remove because it only have this point of attachment, right? I guess. Hey Robert, thank you for joining. Looks like maybe the distance from the support and the surface was a bit far. It caused a bit of sag. Yeah, I mean, support is usually all about bridging, right? You're supporting, and then you kind of bridge on top of the support. Maker Me is right. Yeah, thank you for joining the stream. What support do you like for TPU? What supports? You mean if you have dual extrusion, then PVA works really really well. But if you're asking what support type, like tree support or something like this, then the same. I'm a big fan of pillar support, triangle infill, three 80% dense layer, and then one layer gap. And for me, this setting has worked with pretty much everything. And I just keep that one. Oh, 1 millimeter horizontal expansion as well. And that this setting has worked for everything with my experience. Okay, next, how do I print this in vase mode? What is this? Okay, let's have a look. How do I print this in vase mode? What is this? Oh, okay, got it. So you can print this in vase mode depending on the thickness of that wall. If the thickness of that wall is, let's say, 0. 0.7, 0. 0.8, maybe 0. 0.6, then you can print this in vase mode, because you will basically go one way and then come back the other way, and then both will be a little bit under extruded, but I think Cura knows how to compensate for that, and then you can have this in vase mode. So there's basically nothing to do. But what I can see is the walls are too thin. So let me check. I have no ideas what is the yellow one. I don't know why you have yellow and red. That's a little strange. But when I see the STL, then yeah, it should be. I don't know if the thickness is changing, but if the thickness is the same all the way, it's just wavy, then you can print in vase mode. You just ask him to print in vase mode, and then you put the extrusion width to be half of your thickness here, and then that's done. You should be able to print. But if it's too thin, if it's thinner than half your nozzle, then that's going to be hard to print. Or even thinner than your nozzle sizes will be hard to print. Hello, tribe. I still need to print my I don't know how you call this, but you design one with Polymaker, like the thing that all the tribe member print. I need to print mine to print on my desk. So the notice was going to watch some sci-fi. Well, 3D printing is sci-fi, right? I have the TPU in the dryer, blah, blah, blah. Stop reading my mind, blah, blah, blah. Yeah, we have TPU 95, TPU 90, and TPU 95 HF. Yeah, I saw that, Zombie. You just got a sticker. You had all the old packaging. Usually, if you guys want a sticker, you just buy a product that has like if you buy I don't know, PCABS, PCPBT, or all of these products that are not really mainstream, then usually they still have our old packaging, so there is still a sticker inside. When can we expect ASA 1.75 in bronze color? What is bronze color? Like brown? Or do you want the silk, like our silk bronze? Do you want a silk ASA bronze, or do you want an ASA brown, like a regular color but in brown? Feel free to join our Discord. We have a new product channel, discord.polymaker.com. And then in that new product channel, you have access to our product manager directly, and then you can let him know what kind of materials you want, and then people talk about it, and then we usually update on these materials. So feel free. Oh, the shop sign. Yeah. I need to print my shop sign. Okay. So what is this? I'm fairly new to 3D printed, and I've been having this issue a lot of my print. How do I stop this from happening? Okay, so this is the same issue as when you're printing a helmet. For example, Loyal is printing a lot of helmet, right? So if you check, I'm pretty sure if you check inside Loyal's helmet, it looks exactly like this. There is no particular way to solve this except adding some support. The way you solve this is the same way as you improve your overhang, which means higher temperature, lower speed, good cooling, more shells, this kind of thing, and then more overlap between your shell. So all of these recommendations that you give for overhang, then you can do the same here, and then you're going to solve that if you really don't want to print support, because I understand that if you print support in a helmet, that's a huge waste of material and time. But yeah, that's how you would solve it. So I repeat, higher temperature, lower speed, more shell, more overlap between the shell and better cooling. These are the things that come to my mind to solve this issue. Place what I can get, have a design, blah, blah. Weird circular line. What's that? Weird circular line. But it's not weird, right? It's just the top layer, no? Let's get into this. What is asking? Weird circular line. Okay, I like the title. Weird circular line. Okay, so I guess he's new to 3D printing. I mean, that's 3D printing, right? That's how it is. I think that's just the result. Yeah, that's just how it is. This is, this makes me realize that in some people's mind, 3D printing it's still very magical, right? There's still a lot of people that think 3D printing is gonna give you something perfect, right? You just click print and then you're gonna get something perfect. So it makes me realize this, because you see, it's like, what? I printed something and then I have this weird stuff here. Yeah, but that's the technology. That's how it works, right? Welcome to 3D printing. So the website says 30 to 60 millimeter per second for TPU90. That seems very high. So TPU90 is also based on the high flow technology. Why we didn't call it high flow is because 30 to 60 is still not very high, but it would depend on your 3D printer. If you have a direct drive, TPU90, like I said, is based on the high flow formula. So it should work well. 30 millimeter per second is if you have a Bowden, because it's still very flexible. So even though it's based on the high flow technology, then you will still have some issue. But it will be much better than another 90. So 90 and 95 HF are both based on high flow technology, and they are both UV resistant. And that's something a lot of people don't know. And I'm wondering, did I put that on the website? Let me check. Maybe it's my fault. Maybe I didn't put that on the website. TPU, TPU90 and TPU95 HF. Sorry. TPU90 and TPU95 HF. Did I put? Yeah, I put it. Maybe I should put it in big. Maybe I should put it here. But TPU90 is easier to print with similar flexible high melting index. If you go and check the melting index of TPU, I will show you. And then it has a high resistance to sunlight and UV light. So a lot of people talk about ASA, blah blah blah, but TPU90 and 95 HF here display excellent sunlight and UV resistance. There is UV stabilizer in our TPU. So just something if you didn't know. And then if you go and check the melt index of both TPU, so if you check, that's the TPU and then the melt index. So you can see this is our regular TPU95 is 4.5 gram per 10 minutes, and you can see that was tested at 210. And these ones are so high flow that we had to test them at 185 degree. And for the same amount of force, but for 25 degree less, then it's producing TPU90 6.1 gram per 10 minute, and TPU95 HF 9.3 gram per 10 minutes. So these are really high flow TPUs. He's serious. I asked about 2 new filaments and he answered me like in a day. Join our Discord. We're pretty active. We're trying to be responsive also. Where was I? Sorry. Oh, okay. I have a good direct drive. Yeah, then you can try. You can push it. In vase mode, you're gonna go crazy fast. If you have retraction involved, you need to do some tests. But if we do a CNC kitchen test, then I'm pretty sure maybe I will send Vice is helping with the CNC kitchen test. So maybe I will send him some TPU if he's willing to do the same test with TPU. That would be pretty interesting. I've been thinking of building a filament extruder as my next purchase. I want to try mixing color additive. Anything you think I should watch out for? You mean like buying the 3D Vo, right? 3D Vo. This one, right? Like this type of machine. Well, CNC Kitchen made 2 or 3 videos on testing, mixing some additive and fillers for the 3D Vo. So I would at least watch these videos, like how to use the machine and how to extrude your own filament. But no, I mean, if the goal is to experiment, then there's nothing to watch for. Quite the opposite. If you want to experiment, then experiment. Hope to print more TPU soon. Yes. Art March Animation. Do print more TPU. How worried should I be about Polymaker TPU absorbing water? How worried? Yeah, you should be worried. I mean, you should be worried with any polymers. But to give you an idea, PLA, if there is a spectrum between worry and not worry, then we have not worry and worry. So you have PLA, ABS, ASA, PC, TPU, PTG, PVB, nylon, PVA, something like this. So that's the spectrum a little bit on how worried you need to be, if that's the question. I'm about to run TPU 95 on 90 millimeters per second. I want to see how fast it goes. If it's the regular TPU 95, then it's just a regular one. I mean, it's pretty good already. But the HF, if you can run TPU 95 on your setup at 80 millimeters per second, then the HF version of TPU 95 would be way faster. I mean, to be honest, the TPU 95 HF is faster than the Ender 3. Like I told you, right? I printed it vase mode, and then I wanted to reach the point where I under extruded the filament, but I reached the point where the printer couldn't keep up with the speed instead of the material. So, but again, that was without retraction. That was in vase mode. A few days ago, watched an English dub, sci-fi, blah, blah, blah. Blah, blah. That's why I'm not even opening my good nylon until I have a use. Yeah. Scares me. Thanks, Nicolas. Stream went great. You're awesome. Thank you very much, 3D HP. Nothing as nice as the 3D bow. Want something I wouldn't mind killing, adding random PLA. Cheetos does PLA. I think CNC Kitchen made a coffee PLA. I think he grinded some coffee grain and then he mixed it with PLA. Hi Polymaker, I just got your filament I want today. Thank you. Oh, great, Nick. Feel free to share your creation on our Discord. I've dried my PVA Plus. PVA Plus? There is a PVA Plus now? You guys know what I feel about plus stuff, right? What's a PVA Plus? Prima Select PVA Plus. Rating. Not a very good rating. Oh, Race really has a PVA Plus. Okay. What's a PVA Plus? Yeah, sorry. Maybe we can keep that for Printbuster. Today is about answering questions. Sorry. Just got my intention. Why there is a PVA Plus? What else there is? PLA Plus, PTG Plus, ABS Plus, PVA Plus. Is there a nylon Plus now? Do you guys know a nylon Plus or a Polysmooth Plus? Soon we are going to release a printer Plus. What can I do to help make these uneven layers better? Well, let's check the picture. Okay. Yeah, that's a printer. That's a printer issue. There is a nice video from a CNC Kitchen that there's two video from CNC Kitchen that go through this specific issue. I don't remember what was the. I think it had to do with belt tension, if I remember well, with the bed heated cycle, and then bed tension, belt tension, bed heating cycle. I don't remember if there were other things, but I think that was the two main thing. I don't remember, but I don't think any particular material setting will help with that. I think it's definitely printer maintenance. I think would solve that issue. That's my guess. I don't know if you guys have some other ideas here. Do you recommend slim pickings? Do you recommend any different print settings for your glow in the dark versus regular PLA? Print settings should be pretty similar, maybe a tiny bit higher temperature, like 225. But the most important is to use a hardened nozzle. So if you are going to use a hardened nozzle, then you are going to have, I don't know, stainless steel nozzle. And then the problem would be that the hardened nozzle, and the problem would be that the temperature won't be transmitted to the material very well. So you will have to print at an even higher temperature. So if in a regular brass nozzle you print at 220, 225, then on a hardened nozzle maybe 230, 235 to compensate for the heat transfer capability of your nozzle. But yeah, slightly different. Polymaker, looks like you got your VPN issues solved. Not really. It's it's the same setup. Everything is the same, but sometimes we are lucky, sometimes we are not. So it seems like today we are lucky. So it's good. Let's just enjoy the day. I only print in Polymaker Plus. Yeah, we should release Polymaker Plus. I will post on the Discord after semester is over, exam is near. Oh yeah. School first. Well, it jumped. Tighten your belts and wheels. Lube your Z. Yes. Okay. So yeah, I guess I'd say check the belts. Yeah, I agree. Plus. Watch my TPU print live on Twitch. Zombie Hedgehog. Okay. Let's put that in the background. Let's put Twitch. It could be lost wheels. Soon plus will be considered normal, so they will make the plus. Yeah, I really Zombie Hedge. How do you write that name again? Hedgehogs. Yeah, you should be able to print pretty fast. Which TPU did you have? Oh, TPU 90, you said, right? It could be lost in blah, blah, blah. Lead screw wobbles. Yeah, I'm pretty sure is all to do all of this kind of thing on your printer more than the print setting. Z roller alignment check too. Yeah, that's a good point. V wheel. I keep forgetting everyone still have those. PLA Plus Max Extreme is my favorite filament. Yeah, we are going to go crazy. I don't know in 5 years how the PLA is gonna be called. Yes, I have a hardened nozzle coming. Great. So just remember that the temperature are a little bit different between brass nozzle and the hardened nozzle. Nick is streaming with Internet Plus. Yeah, definitely. Today we definitely have an Internet Plus. PLA Plus Infinity for the win. PLA Pro. Yeah, PLA Pro is a good name. PLA Pro Professional. Okay, let's continue our troubleshoot. Can I do something like this, and then this, then this, and then something like this? Yeah. How good is this? But perfect. Now we can have a look at our TPU 90 print at the same time. Well, that's an Internet Extra Plus Max, right? I'm looking at the stream. I'm streaming. I'm on Reddit. I'm opening some tabs. That's What's happening? We have, I don't know. We're very lucky with our internet today. Let me close this one. Let me put this one here. Let me close that one, and let me close this one. Okay. Why are the ridges on the bed leveling square and holes at the back? Why are the ridges on a bed leveling square and holes on the back? I don't understand. Oh, okay. So he's asking why you have this strange stuff here, and then why you have the holes at the back, right? But this is just over extruding. Either over extruding, either your nozzle is too close to the bed. Most likely is your nozzle too close to the bed when you're looking at how it's how it's printing. It's like squishing down the material. I mean, it's pretty good if your goal is to have a good layer adhesion, but some bed adhesion. But sometimes squishing it too much will mess up your bed adhesion. So I would just recommend a little bit of a Z offset if you don't want to re-level your bed, or just re-level the bed so that it's a little bit further away from your nozzle. But it seems the bed seems level, so I would just do a little bit of a Z offset on the slicer to solve that problem. Benshi, let's go. I did the email I sent you help browser with building VPN help you. I tried a few of them. Unfortunately, they are less stable in China than I would thought. The Astril is really the most stable one, and somehow is working well with Chrome. I tried Safari as well, and I tried some of the one you had with the embedded VPN. But I've had more luck with this. What we can do is, if it drops, if we have a stream that we're not very lucky with the internet, then I will switch to the one you send me. There's a couple of them, and see if when one is not working, the other is working. That would be great. Then I can just switch back and forth to the one that is working the best. It's the build plate. Yeah, I think so. Remind everyone to press the like button. Thank you, Kenneth. By the way, I'm thinking I may have a different YouTube channel. We may have the Polymaker channel with our regular video, because we are going to make more case study video. We are going to make more explanation video, but that will be handled by Luc. So Luc is going to make more videos, like 5 to 10 minutes video on case study and stuff like this. And I don't really want to have all the lives that are in between this video. Maybe a lot of people don't want to watch like these big lives. So I'm thinking of have a Polymaker live channel. And then on this, we're going to have all our print busters, the Q&A, and the Saturday Hangout. We are going to put them there. So that's an idea we had in order to not mix the company video and with all the lives. I need to make a printer mount. Polymaker, do offline test instead of emergency online. Do offline test. Yeah, this is a good point. Have as many channel as you want. Okay, printing PTG and getting weird stringing. PTG stringing, ding, 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 ding. Dry your filament. I'm pretty sure. Okay, I bet you that half of the recommendation we are going to see is drying the filament. Okay, let's check. I'm pretty happy with my print, but I'm getting stringing. You're doing pretty well if that's all the string, blah, blah, blah. So no. So when I adjust retraction, I also found that just a little bit, blah, 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 plastic melty, blah, blah, blah. Okay, only 2 recommendations, and none of them is talking about drying. So I guess I'm wrong. But yeah, if someone PTG, oozing, or stringing issue, then always say the same thing: dry your filament. And oh, the print is finished. So did it fail? I missed it. Did it fail? Oh, it's watched over by one of the awesome dinosaur. Oh, I missed it. Did it fail? Okay, let's see what's gonna be the next print. Yeah, so I dry the filament, retraction, and but that's some strange. What is this kind of stringing? What is that? Wait. How can he has this kind of wait? Where does that come from? Let me think. Let me think. Where, where does that come from? How can he has this this thing that goes vertically? Hot air gun will take care of stringing. Yeah. I mean, you can solve. I mean, these are not stringing. These are like I don't know, the filament growing by itself. I mean, this filament is alive. I don't know. Maybe somehow during the print. I don't know, because I can see that you always have like this kind of thing that is stuck on your nozzle, right? And then later in the print is gonna be transferred to your print. But like three of them like this, and then vertically, I have no idea. Usually, the best in this case is you print another one, and then you just look at it. Whoa, yeah, yeah, that's a zombie. That's definitely a TPU common issue. Um, well, I guess you just proved that it's not that high flow, right? I don't know what happened, but what printing temperature are you at? Yeah, I don't know. Sorry for this one. I have no idea where this kind of thing can come from. I would just look at. I would just print it again and just look at it, and then see where does that come from. I guess it's something that is on the nozzle, like in some other part of the print. It's on the nozzle, and then it's just deposited somewhere else in the print. That's my guess. Um, plus 10 flow is a no. Yeah, I think the CNC kitchen would be great on that one. Z hop, no retraction. Um, yeah, I'm not, if there is Z hop, then it would have, Z hop makes retraction, makes stringing worse, especially with PTG. So if he would have Z hop activated, then the print would be really worse. As the hot end lift off print, Z hop. Yeah, I'm not sure it's a Z hop. Extruding too much could be, but then the whole print would have. Yeah, I'm not sure. I see do sometime with PTG that hasn't been dried. Yeah, definitely. The first thing I would recommend is drying PTG. But for this particular thing here, I guess that would be solved with the drying, because I think that come from artifacts from the print, and I'm pretty sure drying would solve that. Okay, looks like we are ready for another TPU print. I cannot figure this out. I like the picture. I like the picture with the title. It's like a very simple picture of. Okay, so yeah, I guess I get bed adhesion is what's wrong. Pre This is a skirt. I guess it's sorry, a brim. My guess is a brim, because he go from the outside to the inside because the print stopped here. So this is a brim, and then print hotter, print slower. Maybe add some glue stick, but it seems to be a texture bed, so it shouldn't need. Bed at 55 degree, print, if it's PLA, print 220, 225, the first layer, 30 millimeter per second. Make sure you don't use the fan. All of this stuff for bed adhesion, and I think that should be fixed. blah, blah. 225. Yeah, 225 should be good, but I'm guessing a 90% flow in the slicer. So what's the volumetric speed on that you are trying to achieve? Why is there a gap? Okay, where is there a gap? Let's check. So, where is there a gap? Gap. Oh, okay. Huh, interesting. Well, definitely under extrusion here, but now the question is why here it's printed well and here is not printing well. Interesting. So that's the top layer, right? I mean, it's definitely under extrusion because even the top layer, you can see the gaps between the line. So he's printing at a too high volumetric speed for this printer. But I'm just surprised that here is really struggling compared to here, because here the settings are the same. This is the shell, and this is the outer shell. This is the inner shell, and here's the outer shell. This is the inner shell. But here's the inner shell is a little bit compensated by the infill here, like the top layer. But here it's not compensated by the top layer because it loses all of this. So my guess is just volumetric speed. Just decrease your printing speed or increase your printing temperature. That should solve this. Or or calibrate your printer. E-step calibration, depending on which team you are, flow calibration, slicer flow calibration, or E-step calibration. We had a lot of discussion around this, so I'm not gonna go into the details. I haven't tried Polymaker filament yet. Oh. I haven't tried Polymaker filament yet. Atomic and Prusa are my go-tos. Would love to hear what Polymaker does differently, and if there is any practical or engineering filament I should try from you. Well, that's a whole stream topic, right? I would love to hear what Polymaker does differently. So a quick summary. How would I put that? So we create filaments in order to solve problems. So what our filaments are based on a lot of different technology that we're trying to develop to solve 3D printing issue. I'll give you some example. Some of our first filament was Polymax PLA. So we solved the brittleness of PLA. So you've seen a lot of PLA plus, PLA tough, or this kind of thing. We were the first one that released that type of PLA, which is called Polymax PLA, and still available today. Wood filament. You've seen a lot of wood filament out there, and they all have the same problem. They clog the nozzle because of the wood powder. We solved that problem with the foaming technology. So we have a wood filament that doesn't have wood powder inside, but it mimic wood because of the foaming technology. So nano reinforcement technology, stabilized foaming technology, and then we have, for example, Polysmooth, the very first of its kind. How to smooth a model without using nasty chemicals like acetone. So we developed a filament that is as easy to print as PLA, but can be post-processed with IPA, alcohol. And that's our layer-free technology. And then when it comes to nylon, all the fiber reinforced nylon, we developed a fiber adhesion technology, which is to make sure that the fibers adhere as well to the matrix polymer. And that's also a big difference. So we have 6 different technology. We also have ash-free technology. So each of our material are developed specifically for 3D printing to solve 3D printing challenges. So that's kind of how I would summarize the difference between Polymaker and other company. And I'm not even talking about, all the community involvement that we're trying to do, the customer service we are providing, the quality of our product in terms of our eight-step quality control. all of this, I'm leaving it aside. I just do a summary of the actual technology that is in our filament. And I even forgot the best one, which is jam-free technology in our PLA. All PLA are the same, except Polymaker PLA. The filament itself has a heat-resistant temperature of 140 degrees to avoid heat creep issues. So all of these are kind of what set Polymaker apart from other filament company. And then your second question is there any practical or engineering filament I should try from you? I don't know what you mean by practical of engineering filament, but another good thing about Polymaker is you're going to have access to a large amount of data to make your own decision on what material is the best for you. So if you go on our website, us.polymaker.com, and then you click on material comparison, you're going to arrive on a Power BI. Let me put it in big screen for you. And then on that Power BI, you're going to have access to a lot of data. So if for you, I don't know, engineering materials means I don't know, means a very rigid material, then you can check the Young's modulus and go PS6CF is one of our most rigid material. But if you check the wet state, then maybe you would look from some other material. So I don't know, what is engineering material, but you can try even just our PLA Pro could be an engineering materials for you. Our Polymax PC could be an engineering material for you. We were also the first company that released a printable PC on desktop printer. So we wanted to bring engineering material to mainstream. We were also the first one that designed warp-free nylon based on the understanding of semi-crystalline warping issues. So there is so much that differentiates Polymaker from other filaments. The only warp-free nylon, the first tough PLA. We have our breakaway support, the first breakaway support, the first wood mimic that doesn't clog your nozzle. And I can go on and on with pretty much the whole portfolio. So hopefully that answers your question, Forrest Gibson. Zombie, my suggestion is not to try Polymaker. You will not want to use another brand. Blah blah blah. Hey, what's up? Come out and PLA. Just come to see me. I will show you all type of Polymaker. Glow in the dark is fun, excited, blah blah blah. PLA Pro is great. The ASA, yeah, our ASA is also very popular. It can also be considered as an engineering material. If I can get my setting good, I might do a blaster in ABS. I've seen I think there is Make a Meals Right. I think your design pop up on the screen just for a few seconds. Forrest Gibson, we design filament to solve problem. This solves me instantaneously. Exactly my type of thinking. I love those example. We'll buy a shipment tonight. Awesome. Let me know how it goes. We have a Discord. We also like to talk about the science of 3D printing. We actually have a show for that is called Print Busters. And then we go really deep into filament phenomenon. And, we talk about warping, stringing, jamming, this kind of thing. And then the more we understand 3D printing phenomenons and the science behind 3D printing, and the better we can design our filaments. So feel free to join our Discord or other live stream where we talk more about the science of 3D printing. The community helped us a lot in designing filament and finding the right way of development. Okay, great. Next, bed adjustment problem. Okay, so what type of problem he has? That's really not good. I would. It could be a piece of art to print on such a bed. That would be pretty fun. You check your hardware and then you check your screws and then I'm not too sure what to say on this one. Next on the list, is there a setting in Cura to generate support that are easier to remove from the build? These supports surround the actual print and are near impossible to remove cleanly. Yes, there. Well, tree support, I guess, shouldn't have this issue like going around the print. Um, and then you can customize. You can customize your support so that you don't have this issue. Oh, did it fail again? The TPU print? Yeah, looks like so. So what I was about to say. Yeah, you can customize. So you have some pillars. What you can do on Cura is you can put a box, and then you can tell Cura that to not put any support on that box. So you can make sure that there is a box to open your support, so that it's easier to remove. Yeah, there's many ways of doing this. But usually, I mean, it's not that hard to remove. You just have to cut through. Uh, like when you print the animals I design, you will also have sometimes support that go around the limb, and then you can just cut them. Should be okay. But yeah, like I said, there is ways to open those support. Well, it's really been an hour and a half. That was so fast. Oh, really? Okay, I would have thought it would be around 45 minutes, so kind of double the time. Yeah, a bit too fast for my setup. Yeah, I mean we can do some more tests. Whoa, what is happening here? Whoa, that's not good. I was printing, then suddenly the thermo thing detached. I did not notice the nozzle go crazy and smoke came out. The I said PLA is burning in 214 where then I put back the thermo thing and it was 350. Well, that's almost degradation temperature for polymers. What I'm gonna do? Well, yeah, that's so dangerous. I mean, the sensor, the thermal sensor, if it if somehow get disconnected or something, then that's very bad. They should have they should have some kind of safety because you're they should have some kind of safety that says, I don't know, if you have a huge difference between the thermal sensor and the command that you're putting on your on the resistor, right, that is heating up, then if you are heating up for 1 minute, and then the thermal sensor is at 25 degree, like room temperature or something, or doesn't give any data, then you should shut off the printer directly. I mean, I don't even know why it kept heating up. They should have some kind of safety. That's very bad design. And that's not the first time I hear that a printer is badly designed for safety, by the way. um, the first layer looked amazing though. Yeah, I guess the first layer is slower than the other, I guess, right. A good improvement for support is to make the Z support distance 1.5 your layer height. But that's impossible, right? You cannot do 1.5 your layer height. It's either 1, 2, 3. It has to be a whole number, right? Or can you? I mean, in my thinking, the slicer cannot do half of your layer height. It has to be a multiple of your layer height. Otherwise, the whole layer is at half your layer height, I guess. Thermal runaway, not good. Thermal runaway, yeah. Looks like another 8. Start over. I like the V6 design. Thermocouple, replace heater and sensor. Yes, yes, yes. They don't have thermal runaway protection. All printers should have that nowadays. I hope so. I hope so. It does shut down if the printer does not heat as expected. Oh, really? Okay. Well, it looks like his printer didn't. I even get that during nozzle swap and such. Yeah. Forrest Gibson. Yeah, engineering is broad. It's just nomenclature. I see other brand use. I print NUS part for the film industry. I use material that has good surface finish, plus can mount thing on hot cameras. Mounting on hot camera. Yeah. Good surface finish plus maybe Polymax PC. I love the finish of polycarbonate, and it's pretty heat resistant and creep resistant. I see CFPA on your website. I'll have to try. Yeah, I mean, depending on what you mean by hot camera and what kind of stress, because nylon are not very good with creep, right? So if you have, if somehow it's a bracket to hold a heavy stuff on your hot camera, then over time the bracket will deform, right? Maybe PA12 CF could help with that. But if that's the case, then Polymax PC would be better for creep issue. If your printer allows it, set up auto shutdown. Yeah, you should. You should. These little test crap are super nice though. Send me your favorite TPU print on discord.polymaker.com. Yeah, if you guys have some TPU print that you want Zombie to print, then you can send it to him. Okay, what's going on here? Can't connect for you, okay, the software stuff. Help, I need to make an intentionally bad print for demonstration purpose. Which Cura setting should I mess with for the worst result? That's an interesting question. Like, he's trying to do a bad print, but he's so good that he don't know how. all his print are coming out perfect, and he's like, oh guys, I need help. Like, all my print are perfect. How do I do to make it bad? That's interesting. I mean, pretty much any setting on Cura can end up with a bad print, right? Like, what setting, if you go to an extreme, then would have a I mean, it's usually hard to make a good print, but it should be very easy to make a bad print, no? Who has problem of making a bad print, really? Who has this trouble? I wish I had this trouble. Polymax PC, okay, noted. Good thought with the nylon. Yeah, try it. Depending on your printer also. I mean, Polymax PC requires an enclosed chamber, like depending on what size you're printing. If it's fist size, then an enclosed printer, 40, 50 degree inside should be good enough. If you're printing more than fist size model, like bigger than the fist size, then maybe you'll have to. It depends on what printer you're using. Flow at 150, temperature at 300, retraction 100 millimeter. Still haven't perfected bridging. Yeah, let's see what's going to be the best. This keep happening. I don't know what to do. I've tried it all. This was done with my Ender 3 Pro and Cura slicing software. Yeah, more shell. You need more shell. So for this particular issue, you need more shells. This will solve the issue. You need more infill and more shell. You can use gradual infill, and in order to not have like too much infill the whole way, and then you need more shell to properly do that rounded stuff. So to solve that issue, and then here, well, I guess this is just a support issue. Just we already talked about support. What's that? Can someone explain this phenomenon? I'm totally baffled. We are using the Dice Design Prusa Extruder 1 nozzle with propylene. Oh, why it does like this? Okay. So that could be usually is partial clog. Usually a partial clog is going to give that thing. But I doubt this extruder, because it's a pallet extruder and it's a pretty good extruder. I doubt there is a partial clog. What could happen also is the viscosity of the filament is pretty high, which makes it do you remember we were talking about elastic deformation in the nozzle? So maybe the fact that it deformed in the nozzle and then reshaping after the nozzle is creating a certain uneven stress that is, kind of bending the filament a bit. So it could be this also. But it's pretty funny. But that happened also on regular printer. I've seen this on regular printer as well. It's usually a partial clog, which means if you're printing at a higher temperature, that will solve the problem. If you decrease the viscosity of the material, so I'm pretty sure here, if they increase the extrusion temperature, then I'm pretty sure they will have less of an effect. And that could actually be a great proof for the elastic deformation of warping. If you have this on your printer, try to increase the temperature and see if that decreases the phenomenon. Oh, is that this guy? This guy posted 2 times how we can help him to make a bad print. Oh, is that repeating? Repeating. Okay. Nothing bigger than fist size. I have an enclosed Prusa pre-ordered that Bamboo Lab X1 carbon as well. Oh, really? I think you're gonna be happy with that Bamboo Labs. I've seen a lot of good things, and we spent 4 hours, I think, in the last stream trying to dissect that Bamboo Lab, and we haven't even finished. I think we barely scratched the surface in that 4-hour stream. My goal is to set up a 300 millimeter enclosed Core XY style printer. Temperature is too high. I would say the opposite, Rover. I would say if you're talking about that strange extrusion here, I would say the opposite. Bang enter. It's the okay. Let's do a couple more. Is this excess filament retraction issue? So what issue? So you're talking about the spider web here, right? Hey guys, up until yesterday, I've never had issue with my retraction setting on my Ender 3, blah, blah, blah. Now I started leaving this leftover on my print. If this because my retraction setting, kind of random that do setting, I've always had started working poorly on the sudden. Okay, so for me, this is called spider web. So you remember, for me, oozing, stringing, and spider web are different. Okay, they are all different. We talked about oozing on Discord. We talked about stringing on Discord, how to solve, what's the root cause, and spider webs. The root cause. I like how Zombie put the dinosaur looking at us, going back and forth. The spider web for me is caused by the fan blowing the polymer away from the nozzle and then creating these spider webs, right? So to solve this, there could be a moisture issue. So the moisture is going to enhance that the fact that the fan will be able to blow on the polymer and creating this string, and it could be solved by let me check. Lower temperature, I guess. Lower temperature should help for these. But to be honest, if you don't dry the filaments, then I think it's very hard to get rid of them, except if you shut off the fan. If you shut off the fan, actually, to prove the theory, if you have this issue, then you can shut off the fan and then see if you still have it. If my theory is correct, you won't have this issue anymore if you shut off the fan, because for me, spider webs come from the fan. But to be honest, spider webs, you use a lighter and then you get rid of them very, very easily. Not like stringing and oozing. Stringing and oozing, even if you use a lighter, maybe you can end up with, a little bit of blobs on your print. But spider webs are basically, because they are really, it's like blowing polymers. Looks like the print is not very good, no? Some ice, not bad, but some under extrusion on the bottom layer. Interesting. So yeah, so that would be my recommendation. Well, I will have to go back and watch the stream. Yeah, I mean, it was a Hangout stream, but somehow we got caught by a lot of things. Like I learned what was Core XY like in detail, and then yeah, we did a lot of things. It might be a little bit long to a rewatch, but you're welcome to join our Saturday stream. It's more of open talk. Bring down the temperature to reduce the spider web. Yeah, that can also work. I had a nozzle clog on me, removed it from printer, heated the nozzle in the stove flame or blowtorch, and use a thin wire to remove excess plastic. Yes. Bottom is a bridge. Oh, it's a bridge. It was bridging. Okay. LPT don't pause a TPU print. I don't know what LPT means. Okay, let's do a couple more. Let's do a couple more, and then we're gonna do our giveaway, and then it's gonna be a nice Q&A. Even the spaghetti didn't print right. Even the spaghetti didn't print right. Can you have spaghetti issue on the SLA printer? I thought spaghetti issue was only for FDM. Formlabs, blah blah. Okay, printer adding weird lines in field. What are they? Yeah. So this is typical in Cura. They don't use retraction when moving inside the print. So it's typical. It doesn't matter. It doesn't matter. It's not going to affect anything. But if somehow you want a perfect print inside, then I think there is a setting that forces that retraction, if I remember well. But yeah, that's I mean, pretty much all Cura print, especially with triangle infill, will have this. It's like part of the print. I've seen this everywhere. Well, that's a very interesting Banshee here. After hours of leveling and tinkering, I got a print like this. How do I fix it? Well, that's a pretty bad print actually. Okay, let's diagnose. So it looks like there's only one side. There's a big difference between one side and the other. Yeah, I'm wondering. I mean, it may have some. What looks like Zombie has a similar print. Yeah, I'm not sure. I mean, that's a pretty bad print. It could be so many things. It could be so many things. I'm not sure. The interesting part is one side is good. I mean, kind of good, and the other side is very bad. So yeah, I'm not sure. It could be so many things. It could be temperature related. It could be filament related. It could be the printer. I'm not sure. There's too many things. Yeah, it could be too many things here. I'm interested in seeing if Z-Hub makes better print than not. In my experience, Z-Hub makes worse print. Budget fuzzy mode. 12 people need to hit the thumb up button, please. Thank you. Yeah, we have 30 people on the stream interested in some troubleshooting. That's very, very nice. That's very, very nice. Where to start? Yeah, exactly, Francis. Exactly. When someone come with this type of print and say, "Hey, how can I fix it?" Then that's the perfect answer. Like, where to start? Buy a new printer. Did they have a huge fan blowing on one side? I could be. I mean, usually that's one thing that comes to my mind as slip pickings. When one side is worse than the other, I'm always thinking about fan because most of the printer has a one-sided fan. So it could be. Crappy fan shroud, yes. I'm guessing high temp on a single-sided fan for sure. Yes. I mean, fan is a good starting point because of this double-sided effect. Single-sided fan isn't going to do that. Z-Hub makes things worse. Yeah, I agree. Maker is right. I have the same experience. They are here for my test print. Z-Hub is terrible option to enable. Z-Hub just seems so bad. I tried it and I didn't think it was worth it. Yeah, great. Well, it looks like we all have the same experience with Z-Hub, right? I don't know why they introduced it that. I think they introduced Z-Hub to avoid if you have a print that is curling, then it's not going to catch on the print. I think that's why they invented Z-Hub. But if your print is curling, then you better solve that instead of compensating by jumping over it. Polymaker, in your opinion, what is the best 3D printer and why? Woo! That's uh, again, that's a one stream. That's the one complete stream question. But on top of my head like this, I think the um, for me, if you just get into 3D printing, get a cost-effective printer. Cost-effective means a good value out of what you're going to pay, right? So at the moment, I see that the Creality and the 3 Pro or V2, depending on, it's called Pro here in China, but I think it's called V2 outside of China. And this for me has the best value. There is a five, I guess, a 1 to 5% chance that you are receiving a bad printer, but you just return it and get another one. But if you have a good printer, then for the value, for the money you're going to put in, I think it's a great printer to get started. And I guess that's the reason why it really blew up on the market. There is some other printer, like building a Voron. I don't think is accessible for a lot of people. There's the Loosebot Kick. What's the name already? Kickass printer, I think it's called. I don't remember the price point, but anything that is under $300, like $400 to $300, I think, and has a good value, a good community behind it that can help you troubleshoot, I think is a good idea. The Ender 3, there might be some clone and stuff, but the good thing with the Ender 3 is there is a big community behind. So if you have issues, then you can find answers pretty easily. So yeah, the Prusa, but I guess it comes down to the budget you have, right? Blah blah. Thread printers with the guy who won Wars. Yeah, Robert, that's perfect. There is one guy with a perfect print and he has trouble to have a worse print, and there is a guy with a worse print that has trouble having a good print. We should put these two in contact. The only issue I have with movement is for surface movement. My nozzle leave marks. The best is Prusa Mark III. I have never printed with a Prusa, like never. Not even the original, or I have never printed with a Prusa. I mean, what I usually say to people is, if you're really interested and you consider 3D printing as a hobby, then pretty much all printer would be good enough, because you will have, if it's a hobby, you will have the motivation to tinker and to modify your printer to make it good. If 3D printing is not a hobby, then you better put more money and then get a printer that works. And then yes, the Prusa might be a better option. There's other option, or even the Ultimaker if you're more in a professional environment and really need that ecosystem. But yeah, it depends on so many things. So that's why I say it's more it's a big topic. Z-Hub helps a lot with stopping from knocking over tall support tower. Yeah, but again, Mark and Draka, if there's nothing that is curling, then theoretically it's not going to knock over anything, right? And the 3 is kind of junk now. Many other brands include a lot more for the price. Yeah, if there is other brands that are more cost effective, then yes. Sunlu S8, yeah. Anycubic Viper, Cobra Plus are the best out of the box, yeah. Yeah, it's true. It's true that there is more and more choice, yeah. Anycubic is very solid right now. My default recommendation. They switch Ender part for cheaper copied part, and they are much lower quality now. Oh, okay, I didn't know that. The Bichu, yeah, there is some good printers in the Bichu lineup. For my first printer, I chose Prusa because I did not want to fiddle with things as of now, apart from some PTG first layer small programming print accessory. Yes, Francis, that's That's a good point. If you really don't, if it's not really a hobby to tinker your printer and stuff like this, then you better put more money in the printer. There is a lot of different Ender 3 S2. It makes a difference. Gitex. Oh, that's a long time I haven't heard about Gitex. A30 trading resin printer for them. I have the Pulse XC, Pulse from Madahacker, right? Which is basically a Prusa clone and it's very good printer. Yeah, I've heard good thing about the Pulse printer as well. How? It's not like it's magic on anything. It's just a printer, but it's so commonplace that surprises me. How? Sorry, Forrest. I don't know which message you are answering. It's not like it's magic or anything. It's just a printer, but it's not commonplace that surprised me. Exactly. There's like two printers if you don't want to mod. The A10M dual filament, that was to the one I had the clog nozzle and one side heat break completely clogged. Yeah, I mean, all printer, to be honest, they are kind of I don't know. I've never had. I've had printer that lasts, like pretty much all printer for me that I've tested. I've tested like maybe not that much, right? Like maybe around 15 to 20 different printers I've printed with, and they're all of them where you could print something, but some of them lasted longer than other. Like some of them, even today, they are still reliable. Like the Polymaker, even right now, the old extended 2 that I have are still printing pretty good. And some of them, like one Ender 3 that I have, after 2 months, it started to acting up. Like I had to, I started to have issues that I don't know where it came from. And then I don't have much time to, go and, change some stuff. So pretty much all printers were working well, but some last more than other. I would put it this way. I started Smith Make a Gear M2. Oh, Make a Gear. Make a Gear is an old company now, right? I mean, they were one of the first, no? If I remember well, Make a Gear. But I wanted a dual extruder machine, so I bought a Race 3D. Oh, you go from Make a Gear to Race 3D? Oh, the E2. Okay, well, still. How have you not used a Prusa? Sorry, delay. Because Prusa is not available in China. Or, I mean, I haven't checked in details, but it's not that accessible in China. The X1 looks. Our European office has a Prusa, but not. We don't have any Prusa here in our Chinese office. The X1 looks to be promising for just print and go printing. Time will tell. Yes, I agree. I'm also looking forward to that. I learned a lot with that printer and the A10 part machine. Yeah. Okay, guys, it's been 2 hours exactly, so I think it's time to do our giveaway, and I think it was nice to have this Q&A. This is the second Q&A. The first Q&A that we did last week was not supposed to be a Q&A. I was just testing a little bit the stream, and then it ended up. I have no idea how, but we ended up talking for an hour or plus, I think. But from now on, this is the type of stream we are going to have every Tuesday evening. So I'm gonna go. I mean, there is post on Reddit every day, every minute. If I refresh here, I'm pretty sure there's gonna be a completely new post. You see, 19 minutes ago, 30 minutes ago, 35 minutes ago, you already have some new prints, some new problems. So we're not going to run out of problem every week, and that's going to be the style of this format. So the Polymaker Q&A, and then I wanted to show you my new overlay, but I completely forgot. I have this. It's pretty nice, no? But useless because I'm sharing the stream. Maybe I need to have another kind of overlay. But that's gonna be the idea for this stream. We're gonna go on Reddit. I'm gonna answer in priority the question in the chat, and then once there is no specific question, then we're gonna go and troubleshoot some stuff on Reddit. And again, it's any question, right? 3D printing related, even if it's about our new materials. If you have some question about that, any questions, that's the Q&A session. On the other stream, I may spend a little bit less time answering the question, or I may pick a question, but I will go very deep on that question. And sometimes we can easily spend 1 hour on one question, which I don't want to do in that particular stream. I want to spend maximum 5 minutes per question so that we can have all of these questions answered. 2 hours, cutting the stream short. Well, the main reason is because I need to go to the office. So after I finish the stream, I need to go to the office. I didn't do the stream in the office because of the internet. So I just do the stream here, quick 2 hours stream, and then I'm gonna drive to the office. Thank you, Nick. It helps me to understand better. Yeah, that's the goal. Thank you, Francis, for coming. And then if during the week you have some issue or some stuff, you just write down the question, and then when you arrive on the stream next Tuesday, you just write all your question in the chat, and then we're gonna go through them one by one. Is your internet 5G or is it delivered on fiber or wire? The internet is 5G, and it's well, basically I have the router in my living room behind, and I'm using the 5G. But I mean, it's the same internet as before. I don't know why today is working so well, but we are not going to complain, right? The overlay is nice for the bottom. Is seen. Yeah. I need to change that, because when I'm using the thing at the bottom. 30-minute break, then office tour. Okay, great. Let's do our giveaway, and then we're good. And yes, for the office tour, like I said, once I solve well, first when I can go out of Shanghai, because now if I go out of Shanghai, then I need to be isolated for 2 weeks, and then when I come back, I need to be isolated, this kind of thing, like the quarantine. So it's very hard to go out of Shanghai. So once I will be able to go out, then I will go to our production, and then I will do some stream from there, and then I will show you around. I need to buy some kind of camera that I can connect to the screen, this kind of thing, and then we're gonna do that. I think you guys will love our production facility, especially that we have a new one. So everything is so nice, so clean. All the extrusion line are all aligned, and then it's very, very clean. I think you're going to love it. Okay, I guess is there a lockdown again? No, it's not lockdown. I mean, it's before it's lockdown per house. Now it's lockdown per Shanghai. So if you go out of Shanghai, it's a little bit hard to. There is all of these rules about the quarantine, so it's kind of similar to a lockdown. Okay, Grace, are you guys ready? In 5, 3, 4, 2, 1, drawing for second episode of Polymaker Q&A every Tuesday, 9 p.m. EST. The winner is Kevin Tucker. I've seen this name before. I think that's not the first time. I think that's not the first time that Kevin Tucker is winning. Is Kevin Tucker still there? I haven't seen the name for a long time, actually. Let me check. Yeah, I haven't seen this name for a long time. Maybe he's not there anymore. Or maybe he was just listening. Let's check. Let's wait a little bit. And then if he's not here. Oh, he's here. Great. Congratulations, Kevin, for winning. I've won before, but not the random draw. Oh, great. Yeah, I did remember that name. So you can send me an email there to this email, and then I will send you a link. Or you can contact me on Discord if you're on Discord. Here's my email. So congratulations again, Kevin Tucker. And then I wish you all. Let me get in stream. Yeah, I wish you all a very good night, I guess. Let me check. What time is it there? Should be somewhere 8 p.m. PST. So for you, that means it's 11 p.m. right? So for the standard, for the East Coast, thank you for staying for the stream that late. And then for the Pacific, then have a good evening, I guess. And then I will see you either Thursday for Printbusters, either Saturday for the Polymaker Hangout, or either next week, next Tuesday for another Q&A session. Thank you again, and have a good night for everyone, and good evening. Thank you.